Matter in our surroundings. Hello and welcome to this video on Chapter 1, Matter in our surroundings. In this video, we will be discussing the important points and concepts from this chapter. Our first topic is matter. Anything that has mass and occupies space are called matter. For example, table, chair, food, cloth, plants, are all matter. Now let's see the classification of matter. The ancient Indian philosophers classified matter into 5 basic elements, Panchtattva, which includes air, water, earth, fire and sky. The ancient Greek philosophers classified matter into 4 basic elements which include air, water, earth, and fire. Modern-day scientists have given 2 types of classification of matter. The first one is physical classification, which is based on the physical composition of matter. The second one is chemical classification, which is based on the chemical composition of matter. Now, let's look into these 2 types of classification in detail. Physical nature of matter. Particles of matter are not continuous, rather there are spaces between them. Actually, it is made up of tiny particles of matter, which means matter is particulate in nature. Particles of matter are extremely small and are invisible to the naked eye. Particles of matter are in a state of continuous motion. Particles of matter attract each other with a force that is commonly called intermolecular force. It is maximum in the case of solids and minimum in the case of gases. The intermolecular force decreases with the increase in intermolecular spaces and vice versa. To understand the particulate nature of matter, we can do an activity. For that, take a 100 cc beaker and pour 3/4 of it with tap water and then, mark the level of water. Pour some common salt into the beaker and stir it with a glass rod. On stirring, the common salt disappeared, which means it dissolves in the water. This dissolving or disappearance of common salt in water suggests that common salt is not one continuous state of matter. Instead, it is made up of extremely small particles. The water breaks down the common salt into so small particles that they are no longer visible to the naked eye. The level of water in the beaker does not rise or fall. This suggests that there must be some empty spaces in the water. The extremely small particles of common salt position themselves in the small spaces between the particles of water. Let us do another activity to understand how small particles of matter are. Take a rack of 6 test tubes, each filled with clear water. In the first test tube, drop a small crystal of potassium permanganate. After some time, the color of the solution becomes deep purple. Pour a few drops of this solution into the second test tube containing water. After some time, the color of the solution also becomes purple, but not as deep as in the first case. Repeat the same procedure for the third test tube to the 6th test tube. Each time, the color of the solution gets fainter with dilution. From the above observation, it may be concluded that a small crystal of potassium permanganate contains a very large number of small particles. They are so small that they are invisible to the naked eye. Now, let's go further and learn about the states of matter. Matter exists in 3 different states: solid, liquid and gas. First, let's learn about the solid state. Solids are that substance which does not change their shape under the action of a small force. For example, rock. They have a definite shape and volume. In the case of solids, the intermolecular spaces are very small, and intermolecular forces are very large. Thus, the molecules of solids are closely packed. The molecules in them can vibrate about their mean position but cannot change their position. It is on account of this molecular arrangement that solids have a definite shape and definite volume. Furthermore, they are incompressible. Now let's learn about the liquid state. Liquids are those substances that are characterized by a property of fluidity. They have no definite shape, but they have a fixed volume. For example, water take the shape of the bottle. In the case of liquids, the intermolecular spaces are large and intermolecular forces are fairly small as compared to the solids. Furthermore, the molecules of the liquid have kinetic energy. It is because of this property that the molecules of liquid flow. The third is the gaseous state. Gases are those substances that have no fixed shape or volume. They can flow in all directions and occupy all the available space. In the case of gases, the intermolecular spaces are 1,000 times more than the liquids. This in turn weakens the intermolecular forces. The molecules of a gas are free to move about in any direction. This accounts for the fact that gases have no definite shape or volume and occupy all the available space. Let's look into one more activity to learn that gases are highly compressible as compared to solids and liquids. Take 3 syringes of 50 ml each and remove their plunger and close their nozzles with a rubber cork. Fill the first syringe with the chalk powder, the second with water, and leave the third syringe untouched. There will be no air inside. Now insert the plunger into the syringe one by one and try to push it with maximum force. You will observe that the plunger does not move inward in the first syringe containing chalk powder and very little in the second syringe containing water. This happens because the solids and liquids have very little intermolecular spaces and are least compressible. In the third syringe containing air, the plunger easily moves inward in the application of force, thereby proving that gases can be easily compressed. We hope you found this video informative and helpful. If you have any questions or doubts, feel free to ask in the comments below. Don't forget to like and share this video with your friends. Thanks for watching.